Good evening. Today's problem is another trigonometric problem, and we need to find the exact value of the sine of 11 pi over 12. Now, if you look at the unit circle, or most every unit circle, you will not find pi over 12. I can assure you. Basically, the lowest position you're going to find is pi over 6, and that is at 30 degrees. So you figure pi over 12 is 1/2 of pi over 6, so that angle would be somewhere around here, which would put you at a 15-degree angle, which none of these, it's not one of our special angles, so you're not going to get this immediately. So we're going to have to take a little bit of transformation of this in order to get it into some group of special angles. And the special angles are all the angles that we see on our unit circle. So how can we get, well, pi over 12 would be here, but we have 11 of them. So where are we suspecting this angle to live? Well, if you have 11 of them, there's 2. So that gets you to here. 2 gets you to 30 degrees. So to get to 90 degrees, you need 3 times that. So that's 6 of them right there. So we're suspecting that if you had one more pi over 12, you'd be at 1 pi, which would be 1/180. So you're going to have to back off 1 pi over 12, which means 30 degrees off of the 180. So this is basically, 15 degrees off of 180. So this is at a 165. So we kind of know this is the sine of a 165-degree angle, okay? But we need to get this back into the special angles. That's the challenge. So what I did was I'm trying to break up this 11 pi over 12 into some combination of plussing something, 2 angles. So I'm looking for the A plus B thing here at the moment, which what I'm trying to do is I'm trying to get this into the form of 2 special angles that I know the answer of. That would be one of these identities. So I have the sine A plus B, or I have sine A minus B identity. Okay, so it's the sine, cosine, plus cosine, sine, or in this case, the minus would just be sine, cosine, minus cosine, sine. So it's one of those 2 I've got to get the form into, but the A and the B need to be my special angles. So what combination can I create, break this 11 pi over 12 to get my special angle A and special angle B? So I'm going to try here. So let's see. 6 pi over 12 plus 7 pi over 12. Well, 6 pi over 12 would be 1 over 2. That's a special angle, but I don't have nothing for this, so that's not working for me. Okay, how about equals pi minus pi over 12? Well, that's good, but this, no good. So no good here. So let's keep trying. How about we do 8 pi over 12 plus 3 pi over 12. Wait a minute, this might be something. So what's that? So you can take this and put a 4 in there, so you get 2/3 1/4. So this is 2 pi over 3 plus pi over 4. Okay, wait a second. That might do it. 2 pi over 3 is 120. That's one of my special angles. So there's 120 degrees. That's good. How about pi over 4? Pi over 4 is 45 degrees. So you see these two angles added together is 165. So I'm good. That's my answer. So there's my A, there's my B. Okay, so let's now dig out the identity that we were going to use. It looks like we're adding the plus identity. So when I use my identity sheet, I'm using the sine A plus B. So it's sine cos plus cos sine. So let's write that out. It's always good to write it out. So we have the sine A plus B argument equals sine A cosine B plus cosine A sine B. All right, now we identified that that's A, that's B, right there. So let's put them in. We get the sine A is the sine of what? 2 pi over 3. And the cosine of pi over 4 plus the cosine of 2 pi over 3 and the sine of pi over 4. There you go. That's our identity here. And I'll put a box around it so you know. And now we expanded this original problem into something that didn't have anything to do with the special angles. It now has an identity we pulled out that broke it up into two special angles. And we have the unit circle that gives us the answers to that. Well, as you remember from your basic trig, that on a unit circle, the radius is 1. So when you talk about the definition of the sine equals y, sine of an angle is y over r, but if r is equal to 1, then we just get y equals, the y position is equal to just simply the sine of the angle. And likewise, the cosine of some angle is x over r equals 1. So we get 1 times cosine. So x is really equal to just the cosine of the angle. So now when we look at the angle, 2 pi over 3, the sine of it, 2 pi over 3, is just the y position. So the y would be square root of 3 over 2 here. So we have square root of 3 over 2. Square root of 3 over 2 here for the y at that position. Now what's the x position at pi over 4? Pi over 4 is square root of 2 over 2. Square root of 2 over 2. Okay. Plus now, what's the x position at the 120 degree angle, or 2 pi over 3? Minus 1/2. Minus 1/2. And what is the y position at pi over 4? So that's square root of 2 over 2. Okay, so far, looks like we might have this. Let's multiply these together and see what we get. So I get, bringing this equation here down, I get square root of 3, square root of 2 over 4 minus square root of 2 over 4. So, I mean, you could try to play more with this if you wanted to, but I'm getting, I get everything over square root of 3, square root of 2, minus square root of 2, all over 4. Okay, so I could break it up one more time. Square root of 2, square root of 3 minus 1 over 4. And that looks to be the answer for now. So the sine of 11 pi over 12 equals this. Now, we can check this out on our calculator, of course. So let's try. All right, we'll bring in the trusty calculator and use, so here's the check. I call that the check with what? The calculator. We should come up with something close to this. So let's do the math and see what this is first. So I have square root of 2. Okay, 1.14, 1.41 rather. Okay, 3, square root of 3 minus 1 is times 0.732 over 4. So I'm going to multiply that times 1.41 equals, divided by 4, assuming I didn't make any problem, I get 0.258. Okay, 0.258, and that's plus. Okay, now let's check with the calculator doing sine of 11 pi over 12. In the radians mode, of course, 11 divided by 12 equals times 3.14. All right. And let's hit the sine of that. Well, it's a little off. It's 0.26. So maybe I made a mistake here a little bit. I don't think so. 11 pi 11 divided by 12 equals times 0.14, 2.78. Now do the sine. I'm getting 2.6. So it's kind of close. It's 0.258, 0.26. It's basically equal. The round off errors occurring here are going to make it different. So that's the way we handle these kind of problems. If you get something that's not standard and you're trying to solve it exactly, of course you could have run this through the calculator. No trouble there. But if your teacher wants an exact value, that means you have to use the special angles. Okay, special angles. And those angles are the ones you see on the unit circle. And so you're going to have to find some grouping of these angles, either added together or subtract one subtracted from the other. That gives you the angle that you're given. And then you can decipher it using an identity, and you're home. That ends this one. Have a good day.